Hello there, this is StringGearCon4, and welcome back to Project Spark. I put out videos like this every week, so if you haven't yet, make sure you've subscribed. Today I'm going to be talking about multi-brains and how to use them, at least the basics. Project Spark themselves, Team Dakota, put out a couple of hour-long stream videos on YouTube. They streamed for a couple hours. Don't know if it was on YouTube, I guess it was. And the videos are up on YouTube. They're like over an hour each, and I skimmed them and watched them a couple times. I tried to understand them, so this will basically just be really condensed versions of it and some basics on how to use it. So, if you're new to multi-brains, what is it? Well, every object in Project Spark, as you probably know already, has a brain. So if we load the squirrel in, it has its own brain with code. Now these brains consist of multiple pages, but they are all within this one brain. You may also be familiar with multi-brains just because I use them sometimes in my tutorials just to organize code, because that's what I use them for mostly, just organization of code, so I always know where everything is, and you can color code it sometimes, but that's what I use it for. However, you can do some pretty neat stuff with it. I've played around with it a little bit with an enemy wolf, and he like goes through several phases, and it's pretty neat. I think that some of the more advanced enemies in Project Spark actually do that too. Just want to verify that. Yeah, let's look at his brain. Said I want to look at his brain. Yeah, see, it uses some multi-brain things, and yeah, more advanced. It's actually not too advanced. Oops, just took a screenshot. It's not too advanced once you get the hang of it, but if you don't know how to use it, it can be kind of hard looking, though it's really not. So let's get into it. So like I was saying, as you probably know already, every object has a brain. However, they can run multiple brains in one object at a time. Let's pull in a logic cube, because I like to use logic cubes for this. It can be any object. You could stick it inside a squirrel, and it would work. And you want to go into I did that kind of fast. You want to go into settings, properties, brain, and set template equal to true. If you're on PC, you can hold Control and click T. And notice how it sort of shades purple. If it's shaded purple, you can probably see it better with this guy. That means he's a template, so he's just a blueprint. All of his physical characteristics, so any attachments put onto him, will also be made a template, so you can duplicate him later in the game. I like to do that with enemies. I'll just drop one in, template him, work him out, and then have spawners spawn him, so I don't have to, whenever I want to change something in an enemy, change every single one of them, or delete all of them and then copy and paste only to find out that I have to redo code. Just templates will work. But it will also keep all the code in here, which can be quite useful. So this code is now blueprint. So if we do, this should actually be on the do side. Display, text, this brain is active. But since it's a template, which means he's only a blueprint, he's not running, so there's nothing being displayed. We can call this code, however, from another object. So let's pull in, say, a rock, an asteroid, and we can say that when once he will, let's go over, and it should be under the brains tab. So we're going to brain, and let's see, multi-brain, and we're going to add brain. Objects, and we'll pick her. You could also pick from the gallery, so if you have any saved brains, which I do sometimes, so if we look in here, I have some brains, which some of them you may recognize, some of them I don't recognize, like Gong. I did not create that. Hunger Mechanic, I made a tutorial on that. Inventory item, perfect dodging, perfect blocking, pickup, those are ones I created, so you can call those, and that's quite useful. So you can follow along, create my Hunger Mechanic again, and save it to your gallery, and then you can just plop it into any game, which is quite cool. So he's gonna run that code. So he added that brain. So everything that was in that thing, in that logic cube, is now in this rock, which is only one line. And this also transfers pages. So countdown timer of 1. Page 2. Put it here. Display. On page 2, not 22. Edit. Edit. I'm on page 2. Let's go into test and you switch pages. That is just adding brains. So if this rock has any code within itself, so if you say have an enemy and then you add this will basically just be like secondary. We can also say on this guy do this. We can just have him say highlight. And you notice that the page only changed for the other brain because this guy's still, the rock is still technically on page 1, while that code that was in the logic cube over there is on page 2. Alright? Adding brains is not the only thing we can do. So, we'll say after 1 second, we will push brain. So what this does is it forces this code onto the current brain, which means it does not kill all the code under it, but if you think of it like blocks being stacked, it gets put on top of it instead of to the side of it. Add brain just sort of builds it out, so it runs both at the same time. This will run only the logic cube. Let's watch. So after 1 second, it switches over to just the logic cube. So it's in essence sort of like switching pages, and you can also, let's see, we're going to want to do this, and we're going to say countdown timer of 2. We will pop this brain. So it switches over to that, switches over to that, and then pops. And you notice that the rock went back to normal, and then it just ran that code again. Pretty cool. So it basically just takes the block right back off, if we're thinking of it in the building analogy. Alright, that's pretty cool. Let's talk about brain variables. So up to this point, we've talked about stuff that basically I just use for organizational purposes. So I'll have my player here, and I'll bring out a logic cube. I'll template it, and then I'll just clean it out a few times with grid mode on because I like it to be symmetrical. And I'll say, now for this character, I'm going to put all my movement code in here. So I'll say that can be movement, and then I'll put WASDA do move. And if I have any like sprinting mechanics or anything like that, I'll just stick it in there. So if we take out of this guy, let's stick to move, and we put under here under ones, we will add brain, objects, and say objects anywhere picker, movement. So we add the brain of movement, and we can move. And then I do like combat and maybe like leveling and, you know, just for organizational purposes, so I can know. And I'll sometimes like recolor it, but that's about the extent that I usually go to. I don't do much more than that, except for effects, which will basically just be like an added brain. So after several seconds, it will remove the brain. And there's that. Let's talk about brain variables, though. So you can use brain variables pretty much in the same way as object variables. So if you know how they work, then brain variables should not be too complicated for you. If you want, I can make a tutorial on how to use object variables and object set variables, because I could probably do that. But instead, for today, we're just going to be looking at, over here, brains, and we can say multi-brain. Actually, it's not in there, is it? Where is it? If you haven't been able to tell, I don't usually find code files this way. But anyway, it's called, we're going to create a new brain variable. New variable of type brain. And we're going to call this, test. And we're going to say test push brain, logic brain. And instead of pushing brain, we're just going to add brain. Alright. So it runs that, which is kind of bad because we put that on. We should set that to once. that was my fault. So after that happens, he just adds the brain and he's good, and that popped the brain. Unfortunately, since we added it to the side, it popped the brain from both objects. There is a way to get around that, and we will get to that. Because that will be channels and slots, but we are not to that point yet. So that's a brain variable, and we can do things with this brain variable. So we can say countdown timer of, say, after 3. We will count timer of number 3, 2, test. All right. So this is where I got confused. I thought that you would do deactivate brain of test. Let's see what that does. And 3. And that appears to have worked. But when I was doing some tests, it didn't work so well. And what I found out was, we would say test brain is active equals false. And this worked even with other brains being moved around at the same time. And it kills that. So if you have a bunch of brains working, like if I remember, I'll probably show you later. If I don't, just remind me, and I'll probably create an unlisted video and show you that with a card on the screen. Hopefully I remember that. So that's how you sort of move that around. And we'll say after 5 seconds, we will bring that to the true. So that's just the boolean. Should work. Did I change the number? I did. That's weird. Why is that not working? That should definitely work. 1, 2. Oh, because it popped the brain. Yeah. From here, I should probably remove that little piece of code. Let's do that. It should kill that, and then pull it back. Alright, now I'm really confused. Back, that's exactly what it's true. Well, anyway. I don't know why that's not working, it should. Now let's talk about channels and slots. So we will add it to channel. And then you can just insert text. So we'll say new text. We'll say this can be display channel. We'll say to slot 1. And we can say 2. I don't know why I'm using so many countdown timers today, but I guess I am. Do deactivate brain. No, I don't think that's right. You say from channel? I don't use this too much. Hang on, let me just look around and see if I can figure it out. In theory, this should work. Yep, there we go. So that's channels and slots. So you can call them from the specific channel and slot. So if you know where it is, you can do that. Which would be good for buffs and debuffs. If you want, I could also make a tutorial on how to do things like that. I've been thinking about doing that, and I could probably do some pretty neat buffs and debuffs. I've done some of that before. Let's actually show, because I do remember, I'm going to show you a way that I implemented this, sort of, in one of my own worlds. It's not very fleshed out at all. It's just something I was playing around with. Let me come back when I get over there. Alright, I'm loading it up right now. ignore it. It's not that great of a world, I know. Alright, so I have this wolf template, and over here I have this wolf spawner, so it will spawn just a couple of wolves. Ignore all that. But that's just a spawner, and this shows you how to use templates. So let's just look at some of his code. It's been a while since I've looked at this guy. So I'm a little rusty on what he all does. But anyway, in these ignore lines, just do what they say. Ignore that line. It's just debug, because I was having some issues while setting it up, and that's why I'm making this tutorial, because I'm figuring other people are possibly having this problem and might be YouTubing it right now. So, here we go. So, this is just stat initialization. So, here we have idle behavior equals add brain of walk. These are all templated logic cubes right over here. And alerting brain will be set equal to add brain of alerting, and then combat flee, background, and he will initially disable brain of the combat brain and the flee brain. And if you're looking, you may notice that some of these are in a kind of order. The background is just stuff that happens in the background, like healing and things like that, and just idle behavior, sort of. Kind of. Idle behavior is actually just walking in a circle. And he will then get alerted to your presence. Then he'll switch over to combat and fight you until he reaches about 1/3 of health, then he will flee. Like I said, background's just running always. So I sort of just arranged the logic cubes so I could see them better visually. That was a really weird sentence. But anyway, so I can just sort of visualize how the things work. So let's look at walk. It will load. There we go. So that's all well and good. That's walking. So he just turns around. And when enemies are closer than 20, his alerted boolean will be set equal to true, and when he's alerted, then he will deactivate the idle brain. Okay, so that's important. I try not to deactivate any brains within themselves, because that could be weird. And then he will it'll alert all his allies, so its boolean will be set equal to true. So it'll basically just go out in a giant extending bubble, sort of. So he will, for every one of his allies that are within a certain range, they will be alerted, and then they will alert anyone within that same amount of range from themselves. So it can just grow, and things can get out of hand pretty quickly. And then the combat brain will be set equal to will be active. I don't know why this is so laggy right now. It was not when I was developing this. And then he will go into combat. So first thing it does basically is just kill the alerting brain. So the alerting brain will be set equal to false, and then he'll go through the combat stuff, which I'm not going through. And then the flee brain will be set equal to true if his health is less than that, and his and then he'll deactivate combat brain, which I just said I don't really like doing, and I don't. And I should probably. This isn't a finished brain, so I don't actually have a what happens if the target is destroyed. I should probably add. And this is the flee brain, I believe. Yeah. So first thing he does is just run away until he gets to 100 meters away, and when it's greater than 50. So when he gets a pretty good ways away, he'll start healing. I think that's what he does. No, this is just, when he is, he's trying to get away, basically. And then his idle behavior brain is active will be set equal to do. So I'll just go back to walking, and then he will also, start trying to alert himself again, and he'll flee. We'll start doing that. So if we actually go in and look at it, this takes a while, because it's a pretty big map. Project Spark and large maps do not work well together. I'm kind of just hoping I don't crash here or something. My timer that was just running jumped ahead by 2 seconds. I think this is the longest Project Spark tutorial I've ever made. However, it's one of the more advanced ones, and multi-brains are very powerful. And I do think that they should be used. Even if only for organizational purposes, like I use them. Here we go. I don't know why this is so laggy. Like I've said before, it isn't usually when I'm doing this. Alright, so then I come back when I reach the rules. Hang on, I found there's this enemy right here which has basically the same combat mechanics. Man, this is laggy. I suppose some of you are probably like, come on, I get that all the time, lag. And I'm sure you do. Usually this only happens, this bag of lag, when there are like a really lot of amount of, like, effects on the screen or characters. Not so much when I'm just running around with only like maybe 10 other props in the world. So they're wolves. They're in their idle behavior now. Now they're alerted. Okay, let's target. So let me just try to not kill them like I did the other thing. Oh, he's running. Let me see if I can get this guy to run away. Yeah, there he goes. So he's now in his flee behavior. Let's try to get him to not go into the water. He's now alerted to my presence. There he goes. And so he just flips through behaviors. That's all that really was. So it's kind of neat. I believe that if you watch the actual Project Spark Team Dakota's videos on how to make enemies, they go through some of that sort of stuff too, which I just sort of skimmed over. I watched parts of it, the good parts. But obviously, I learned enough to use the long frames, which is kind of cool. And you know, I think that's actually going to wrap it up for this tutorial at just about 23 minutes. I think I've hit a record long Project Spark tutorial for this channel anyway. So, leave a like if you found this tutorial helpful, and subscribe if you are into Project Spark and would like to see more tutorials. I will see you in the next one.